2021 by Habna and Zuidema. And Attention Rollout, although was particularly for transformer-based architectures, which was an offshoot of natural language processing, I had to adapt it to use it for a Swin Transformer because the Swin Transformer does not have a CLS token compared to natural language processes. So it doesn't have a way to capture attention weight. So I had to optimize the Attention Rollout. I had to adopt it using my own method, which was very impressive, by the way.
Really?
So I had to capture Attention Rollout through hooks when attention travels in forward passes across different attention blocks. And so I was able to really see how the model or the Swin Transformer understood how it processes its images across its 12 attention blocks, what it focuses on across different blocks of its attention. And it has 12 attention blocks. The Swin Transformer had 12 attention blocks, and it makes its prediction in the final attention block. And so I was able to see that for a Swin Transformer, information is captured in broader patterns in the lower attention blocks. That is from, let's say, attention block 0 to 5. Information is broad. That is, it sees it as a whole, right? It sees the image as a whole, it understands it as a whole, and then as it goes deeper, it begins to narrow its focus into very critical semantic regions, which then influences its final decision. And so I was able to use Attention Rollout to explain Swin Transformer and to show how the Swin Transformer thinks as well. And worthy of note is that Attention Rollout and Grad-CAM, there were some similarities when we visualized them depth-wise. That is when we went deep into the architectures of these vision models. And for Clip, I was able to use Grad-CAM as well. But now, the difference in the Grad-CAM that I used for ResNet and the difference in the Grad-CAM I used for Clip was that for Clip, we understand that the language prompts that we generated for it to guide its vision model, we understand that the language prompts particularly influenced the vision components. That is, we told it, if this is a horse, these are the things we want you to look for that defines the horse. So if this is a zebra, we want you to look for black and white stripes. We want you to look for muscular structure. And these are the things that actually guided the vision component. And the Grad-CAM was able to show that the language prompts actually influenced the vision's ability to focus on very important regions that defined what the animal is, you know, the differentiating components of the animal. And so it was quite interesting to see, and these are some of the very interesting, you know, outcomes of the project.
So my follow-up question here is like, you applied it on the animal data set?
On the animal data set.
Yeah, so if there is some object data set or anything different, so how would you suggest your techniques could be applied?
Hello, I'm Dr. Daniel Farrow here at the Centre of Excellence for Data Science, AI and Modelling at the University of Hull. AI is changing the way that big organizations operate, and that's why we're really excited to be launching a new MSc this January, Artificial Intelligence for Business. Alongside the same great content that we teach in all of our MScs, like Python programming and data science, we have 2 bespoke modules for this MSc about how to use AI and data in a business context. In AI for marketing and sales, our first bespoke module, you'll learn things like how to use chatbots for customer engagement, how to do dynamic pricing. You'll learn about an important concept called customer segmentation. You'll learn about recommendation engines, and you'll also learn advanced topics like sentiment analysis and natural language processing. In the other bespoke module, Big Data for Business, you'll learn an introduction to big data, a key thing in business. You'll learn exploratory and causal analytics, different platforms for storing big data in business, data mining and web scraping, applications of big data in business, and also time series analysis for business contexts. In your 3rd trimester, you'll get to do an original project under the supervision of one of our members of staff. This course is open to a wide variety of people from different backgrounds. You don't necessarily need a science degree as a conversion course where the ideal option for people who are looking for a career change, for example. Please, we're really looking forward to you joining us in this £4.5 million teaching facility here in the DAIM lab. And I'd also like to highlight that our teaching was rated gold in the last Teaching Excellence Framework 2023. If you have any more questions or want specific information about the entry requirements for this course, then I would recommend you check out the website. Thank you.
Now, so if the data set is different, we can change the prompts for clip, for instance, from, let's say we want to capture, let's say a vehicle on a road, right? We can tell it to look for a vehicle of a particular color, of a particular shape. And hopefully the vision component of the model will be able to capture that part being guided by the language prompts that we've provided for it.
So just changing the prompt would just...
Yeah, we'll just change the prompts for it. And
Okay, so what challenges did you face during your research and how did you overcome them?
It was quite a challenging project, but I think from the outset I had a structured view of how I wanted the project to go. So first of all, to overcome the challenge, I first did testing and development to see whether the project itself was feasible, that is, whether it could actually be executed at scale. And so at the testing and development phase, I saw that yes, it was possible to actually execute the project. And then I realized that the models are quite large, meaning that they required considerable amount of memory and computational power. And I then knew that I needed a GPU to do that. So I requested to use the supercomputer at the university. Thankful to the DAIM department and the University of Hull for providing Viper. And I was able to use Viper to overcome the challenge of my own personal, computer, which had lower computational power. So the GPU was an NVIDIA A800 GPU, which was very effective in training those models because we had to train some of these models for weeks. So this was one of the challenges I faced, computational power. Another challenge I faced was actually finding resources. And so I had to explore different resources, the library. I had to read a lot of papers to understand it. I had to use GitHub as well to understand people's code, how they've, addressed the same problem in research and all that. And these are some of the problems that I faced that was quite challenging for me, and these are some of the ways that I overcame those challenges, I think.
Okay, so where do you think your project could impact, how do you think your project could impact real-world problems or industries?
So I have a background in psychology.
Really?
Yeah, and I've always been interested in solving Alzheimer's disease, understanding it, and how we can use research to really improve the outcomes for people living with these conditions. So where I see this project going in the next couple of years, we understand that there's already research using non-invasive methods and artificial intelligence to understand early onset and how we can deter that before it becomes, before it becomes more terrible or before it becomes worse, as it were. So I think my research can influence some of these outcomes such that we can apply some of these techniques to understand some of these diseases using particular data sets such as maybe MRI data sets. There's research using retina images to understand Alzheimer's disease because the brain and the retina share the same embryonic origin. So there's research in that area as well, using the retina as a way to understand the development of this disease. So yeah, I see my research really going in depth and using some of the methods such as CLIP to understand the symptoms to look for, or some of the, as it were, biological markers, right, in the brain, and how we can use this language component to dictate to the vision component of the model to look for that in the images and to tell us when, we can say that this individual might be at risk.
Yeah.
And then we can, look for preventive measures to control that. So across healthcare, I see my research going far. Autonomous vehicle, autonomous driving as well. I see the research going far in the next couple of years. We can really understand, if we can understand how these vision models see, how they operate, how they think, then we can be able to apply them correctly in some of these industries, right? And we can, improve the outcomes for people, as it were.
Yeah. Okay, so were there any surprising findings or insights that emerged from your work?
I think one of the very interesting outcome that I discovered was that these architectures are different. The vision architectures are different, right? But
Different from?
they're different from each other.
Okay.
Right? But there's a fundamental foundation, right, in how they all process images and how they see. That is, they go from broad to narrow. So I think this was one of the things I discovered. And I also discovered that we can borrow from these understanding. That is, we can borrow from this information to create better and improved post-hoc explainability methods, such that if we're saying that, if the research is saying that a Swin Transformer processes images similar to a convolutional neural network, then we can develop a unified post-hoc explainability method that can be applied to both a residual network and a vision-based transformer, right? So these are some of the findings. And another really interesting thing for me was the multimodal model, which was CLIP. I think it was really interesting for me to see that language can actually influence the vision component of a model. And it was quite fascinating because I think I just kept going on and on and on and on. And I kept trying different things with CLIP to see how deep it goes. And I was able to actually see that in the nearest future, I think what would really improve computer vision would be incorporating language components into understanding vision models, not just relying on the vision component alone. That is, we have to now bring in the language components to see how we can improve these models in the nearest future.
Yeah. And what advice would you give the future MSc students working on similar topics?
I think it's, first of all, it's important to understand your direction. I think it's important for you to understand where you see yourself in the next couple of years and how this project or how your current research can help you when you get there or can influence your outcomes. I think I would also like to tell them to start early. I think the earlier you start,
How early?
How early. The earlier you start, the better, because it gives you time to really think. It gives you time to really plan. It gives you time to really construct your research questions and to let that guide some of the methods, some of your techniques, and also some of the results that you would anticipate or that you would expect. So,
That's
I think that's it.
And how was working on this project shaped your future career aspirations in data science?
Like I said, I have a background in psychology and I've always been interested in, understanding how I can use artificial intelligence to improve diseases that affect the brain particularly. So yes, I think this project has propelled me to want to do a doctorate in a field that combines artificial intelligence and brain-related diseases research. So I think going forward, I would like to look for opportunities that explore some of these possibilities and how I can really bury myself in it.
So you want to do PhD?
Yeah, I think I want to do a PhD.
Best of luck. If you could expand your project, what additional areas would you explore?
If I were to expand my project, I think I would explore incorporating quantitative methods to understand the XAI methods that I used. That is quantitative metrics, to understand their outcomes and to see how reliable they are and how trustworthy they can be when they are applied. I think I've also liked to work on healthcare related data. That is maybe MRI images of Alzheimer's disease, I think. I think these are some of the things that I would have loved to explore as it were.
Okay, that's very nice.
Yeah.
So that's the end of our questionnaire.
Thank you.
Thank you for joining.
Thank you very much.